right, so your numbers might be different, but the setup was the same. This is number one. It says a bridge to be built across a small lake from a gazebo on a dock. The bearing from the gazebo to the dock is south 41 degrees west. From a tree that is 100 meters from the gazebo, the bearings to the gazebo and the dock are south 74 degrees east and south 28 degrees east, respectively. Find the distance from the gazebo to the dock. So the first thing I would say is make sure that you would know how to fill in those angles. Like if it said from the gazebo to the dock where you're going from here to here, know that you should be able to fill in that southwest 41 would go there, because there's going to be times in which you're going to have to fill that stuff in, okay? The other thing I would say is, I told you yesterday, but remember to use those north-south lines as parallel lines, right? Every north-south line is going to be parallel to every other north-south line. Every east-west line is going to be parallel to every other east-west line, right? So if you had just drawn your north-south lines along those dashed lines, and then let's just say I gave you this transversal. So do this in front of you if you've got it open, okay? And then look for angles that help you out, right? So think back to your geometry days. You had things like alternate interior angles, alternate exterior angles, and corresponding angles that were all congruent, right? Yes? Do we remember these things? Because those are huge standardized test questions. Okay. So if you look at what's here now, oops-a-daisy. Hopefully you see that 74 and this angle here have what relationship? They're the same because they're corresponding. So if this is 74, right, and this is 41, and those three angles form a line, what's true about those three angles? They add up to 180. So 180 minus 41 minus 74 gives you that the angle inside would be 65. With me so far? Yeah. The other thing is that it gave you in this top, so I need this angle still, right? But in the top angle, it gave me the whole angle 74. This little smidge outside is 78, which means what's inside? 46. So if this is now 46 and this is now 65, I can add those up, subtract them from 180, and I get the last remaining angle, which is 69 degrees. Now, can you solve this triangle? Yes, right? This was 100 in this example, but it was different for other ones. But now you've got one complete ratio. It would be 100 opposite the sine of 69, and you're trying to find distance from the gazebo to the dock. So you're trying to find this side. So let's say that's A or X or whatever you want to call it. It would be opposite the sine of 46. And then cross multiply and divide. So your numbers, again, might have been different, but the setup was the same. This is that 77.05, and in the directions it said nearest whole number. So 77 meters. Get comfortable with those parallel lines. Especially, they'll usually even like dot it. Like there's a dashed line there for you. It's trying to hint to you, right? And yesterday I told you, make sure you look for parallel lines because they're going to help you out. So the 46, this whole angle was 74, but the little one outside was 28. So if you just take the 74, subtract off the 28, you get it. All right, so now that's fresh in your mind. Oh, you have a question? All right, this one says the bearing from Pine Cob Fire Tower to the coal station is north 65 degrees east. That one's already marked. The two towers are 40 kilometers apart. So this measurement here in this example was 40. A fire spotted by rangers in each tower has a bearing of north 80 degrees east from Pine Cob and south 70 degrees east from Colt Station. Find the distance of the fire from each tower. So from Pine Cob, this would be my X. And then from Colt Station, let's just call that Y, but you call it any variable you want. Okay, draw in your north-south lines again. Those are super sloppy, but you get the point. Okay, and then my angles are over here and over here. So if I make this the transversal, this time you actually have alternate interior. This angle matches this angle. So if that's 65, then this one's 65. And now you've got the completed angle here at the top. Add the 65 and the 70, you get 135. And then just like the last example, they gave you the whole angle here and what happens on the outside. So if I subtract the 65 from the 80, I get 15 degrees. Now I've got a triangle in which I have the top angle at 135, this left angle at 15. Subtract those from 180. Oops, 180. And you get that 30 degrees that's over here in this corner. And again, now can you solve this triangle? Yeah, right? You've got your completed side with 40 opposite the 30, so it'd be 40 over the sine of 30 equals, let's say I want to solve for x first, x over the sine of 135, and then 40 over the sine of 30 equals, we called it y, but y over the sine of 15. And then cross multiply 40 sine 135 divided by the sine of 30, 56 point, I did it round, yeah, 57. And then 40 sine 15 divided by sine of 30, 20.71. And they're both kilometers. Questions on that one? So again, your number, like the number for the distance at 40 should have been different, but the rest of it should have been the same. And then the last one said a flagpole at a right angle to the horizontal is located on a slope that makes an angle of 18 degrees with the horizontal. The flagpole casts a 16-meter shadow up the slope when the angle of elevation from the tip of the shadow to the sun is 22 degrees. So the first thing you've got is some sort of a hill, right? So I draw it that way. And then you've got a flagpole on that hill that is makes a right angle with the horizon. So if this is my horizon, I know that this is 90 degrees. And then it says the slope is 18. So the slope going up from the horizon would be your 18 degrees. This would be 18 degrees. This would also be 18 degrees because those are vertical angles. Remember, those are congruent. And then it says it has a 16-meter shadow. So if my shadow is 16 meters, let's say it ends there. Up the slope with an angle of elevation from the tip of the shadow to the sun. So if my sun's over here, tip of the shadow is here. Angle of elevation would go from ground level up or horizontal up, which means that this angle here is 22 degrees. With me so far? So I know only one side length, right? Right now, I know that this angle is 22. There's also parallel lines here and here. If this is my transversal, then where 18 is would also happen here, which means this little angle is also 18. Now I've got this full angle here is 40. This angle here would be the 90 minus the 18, which is 72. And then I can find this angle here by doing 180 minus the 72 minus the 40. So that's 68 degrees. And the question is to solve for h. So the height of my flagpole is here. H over the sine of what the angle opposite it would be 40 degrees would equal 16 over the sine of 68 degrees, and then cross multiply that and divide it. Sine of 40 times 16 divided by the sine of 68. And units is meters. Questions on any of those? So I would say you're going to get more practice before your quiz, but you are going to see word problems. I actually think the ones in the quiz are like a little bit easier than this. And then tests, I haven't made their test yet, but you may or may not get pictures. A lot of times if there's pictures, they might be a little bit more complicated. That's where the parallel lines are going to come into play, so just be prepared for that kind of stuff. We'll review some more word problems because they're going to mix in with your law of cosines word problems. You'll see that today. So you just want to make sure that you attempt them as best as you can and don't get frustrated. All right, the law of cosines is section 2. The good thing about law of cosines is there's no like ambiguous case. The harder part with the cosines is the equations are a little bit more complicated. It's not as easy as just a ratio. Okay, so there's a lot more memorizing. But if you can just memorize one of each of these, you should be able to figure out the rest of them. They follow a pattern. So the first set is called standard form, but it's used to find a side. So if I'm looking for a side in a triangle, then I would use one of these three formulas. Okay, but again, hopefully if you can memorize one of them, the rest of them follow the pattern. If I'm looking for side A, then A squared equals B squared plus C squared minus 2BC cosine A. So the pattern is, if I'm looking for a side, I add the squares of the other two sides, subtract 2 times their product times the cosine of the letter that matches the side I'm trying to find. So if it's B squared, then B squared equals A squared plus C squared minus 2AC cosine B. If it's C squared, C equals A squared plus B squared minus 2AB cosine C. Which means the very last step you're going to do for all of these is square root the other side, right? Because I don't want what A squared is, I want what A is. And then the bottom set, these are now for finding an angle. So they're called alternative form, but they're for finding the angle. So the cosine of angle A is B squared plus C squared minus A squared over 2BC. Cosine of B, A squared plus C squared minus B squared over 2AC. And cosine of C is A squared plus B squared minus C squared over 2AB. So it's the sum of the other sides. So if I'm looking for A, it's the sum of B and C squared minus the square of the one you're looking for. So if I'm looking for A, then I'm going to subtract A. If I'm looking for B, I'm going to subtract B. And then in the denominator goes the other two sides, so 2 times the BC, or 2 times the AC, or 2 times the AB. The good news is that you can get from one to the other of these. So if you can just remember this, let's say, it would be a lot more work to have to derive it, but you could get there. So like A squared equals B squared plus C squared minus 2BC cosine A. Let's say I wanted to solve for the angle. So let's say I want to get cosine A by itself. I would take A squared and I would subtract the B squared and the C squared. And then I would divide both sides by negative 2BC. The negative change the signs of all of those. And it's not in the same order, but it is the same thing as that. If I rearrange it, I get to the other form. So if you forget or if you're unsure and you know for sure one form, you can get to the other one, because I can also flip-flop this. I can go back the other way. I can say, let's say I know this one and I don't remember that one, but I want to solve for A. So cosine A equals B squared plus C squared minus A squared over 2BC. I would multiply both sides by 2BC, so 2BC times the cosine of A. If I'm trying to solve for A, I'm now going to move over the B squared and the C squared. And then it's negative, so I'd multiply everything by -1. I'd get B squared plus C squared minus 2BC, cosine A equals A squared. And that is your initial one, okay? So I obviously would not recommend taking the time to derive every single one of those formulas. It's going to take you more time to do that than it would to be able to finish your quiz. But should you get stuck, should you question yourself, what's supposed to be positive, what's supposed to be negative, what letters are supposed to go together, then you can definitely get from one to the other. You're going to need to know all those formulas. So for me, I would probably just write one of each one and then remember the pattern when you get your quiz, but just make sure you know them. All right, so you will use law of cosines on 2 different types of triangles. So we did law of sines on side-side angle. That was our ambiguous case. And we did law of sines on angle, side, if that's the information that you're given. If you're given side, angle, side, which is this first one, then you're going to use law of cosines. You'll find that when you work it out, you don't have a complete ratio to do law of sines. You won't be able to do the other one, so it should make sense. So we're going to find the missing side using law of cosines first. That's the first thing we're going to do because you have to have all three sides before you can move on to the angles. And then you have choices. You can either find the second side by using law of sines, or you can stick to law of cosines. What you do after that is totally up to you. And then you'll get your second angle, and then from there you can subtract the two angles from 180 to get the third angle. So let's work one out. It says use the law of cosines to solve the triangle and then round to 2 decimal places. So you can draw the picture out. Honestly, with law of cosines, I tend not to because the formulas are letter-based. I don't need a picture. But if it makes you feel better, draw yourself a picture. So if you look here, I've got angle A, side B, and side C. What's missing that I can find? Side A. So A squared equals B squared plus C squared minus 2BC cosine A. The more you write it, the more you're going to remember it. I'd write it every time if you could. And then just plug your values in. So A squared equals 21 squared plus 42 squared minus 2 times 21 times 42 times the cosine of 39 degrees. And then let your calculator do the work. So 21 squared plus 42 squared minus 2 times 21 times 42 times the cosine of 39. And I get 834.114524. Do not round that. Square root it without rounding it. And I get A equals 28.88. You could even type this whole thing in your calculator in one step and just hit enter, and it will go directly to your answer. With me so far? So you can, at this point, either stick with law of cosines and go to your alternate form because you're solving for angles, or you could go back to your law of sines, whichever one you want to do. It doesn't matter. So let's say I go to law of sines. I've got A and angle A, so I could say 28.88 over sine of 39 would equal B, which is 21, over the sine of B. Cross multiply again and divide, so 21 sine 39 divided by 28.88, and I get 0.4576. Second sign that answer, and I get angle B equals 27.23. And then I can find angle C by subtracting the other two from 180. So I could have, after this point, switched to kept with law of cosines. And if I wanted to find B, I would say that the cosine of B equals A squared plus C squared minus B squared over 2AC. And then plugged in my value. So in the calculator, I'd actually have to do cosine -1 because I'm looking for the angle. And then I would get 28.88 squared plus 42 squared minus 21 squared over 2 times A, which is 28.88, times C, which is 42. The thing is, both of them require A, right? So whether, like normally I would say avoid it if you can, because that's something you found and it wasn't given to you. But in either situation, you have to take the one you found. So there's not like a better one, okay? So just do whatever you're the most comfortable with. Once you find that first side, or the last side, you can switch to law of sines, or you can do law of cosines. Questions so far? All right, the second kind is the side triangle. So I think yours says side, angle, side here. It should be side, side, side. So when you're given all three side lengths, I mean, there's absolutely no way to do that with law of sines, right? So hopefully you would know. You have to do law of cosines. The trick here, and this is the trick with law of cosines, is if you're given all three side lengths, you have to do the largest angle first, so it's going to be opposite the longest side. If you do not, sometimes, and not all the time, but you will pull in the wrong answer. It's like pulling in an ambiguous case that actually doesn't exist, okay? So that's what's tricky about law of cosines. If you start with law of cosines, side, 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 and then you switch to law of sines, you can actually create an ambiguous case that is not there, okay? If you start law of cosines and continue with law of cosines, no problem. But if you start law of cosines and want to switch, you have to do the longest side first, okay? And then once you find the angles, you can do the second angle, doesn't matter which one it is, and then find the third by subtracting from 180. So when you look at this, it says use law of cosines to solve the triangle round to 2 decimal places. A is 11, B is 14, C is 20, which means which angle are you finding first? C. So the cosine of C is A squared plus B squared minus C squared over 2AB. So the cosine of C is 11 squared plus 14 squared minus 20 squared, all over 2 times 11 times 14. Okay, so this is the other part you have to be really careful about. You can type that all in one thing in your calculator, but watch your parentheses. You have to group together the numerator and the denominator. Otherwise, it takes, like order of operations, it will take the 20, divide it by the 2, and then do the rest of it, which is totally wrong. You've got to group your numerator and your denominator together. So when you go to type this in the calculator and you hit cosine -1, it's going to already open up a set of parentheses. You need to open up another one. Do 11 squared plus 14 squared minus 20 squared. Then close that parentheses, then hit divided by, open the parentheses again, 2 times 11 times 14, close them, and then you don't have to close them again. It'll automatically do that, but make sure that they're grouped that way. At 105.66. So now you've got two options. Stick to law of cosines, do it again for the next angle, or switch to law of sines, and it doesn't matter which one. So if I keep with law of cosines, and let's say I want to find cosine, let's say I want to find angle A. Cosine of A would be B squared plus C squared minus A squared over 2BC. So 14 squared plus 20 squared minus 11 squared over 2 times 14 times 20. And then again, you could type all that in the calculator. It can do the work for you. You just got to make sure that you group your numerator together. So second cosine, 14 squared plus 20 squared minus 11 squared divided by 2 times 14 times 20. If I had done law of sines with this, so the only benefit to law of cosines is that I'm keeping it exactly what they gave me at the beginning, right? I stick with what they gave me. I'm not introducing anything new. If I do law of cosine or law of sines, then I have to bring in angle C, which is the one I found. If I did it wrong, I'm using it wrong. If I've rounded it, it's becoming less accurate. So the perk to cosines is it is with the original measurements. Okay, if I switch to sine, then I would do 20 over, God bless you, sine of 105.66 equals, if I'm finding A, then it would be 11 over the sine of A. Cross multiply 11 times the sine of 105.66 divided by 20, and I get 0.529, and I do second sine on that. And I get angle A is 31.98. So same answer, okay? It's a good way to check it. But safest is to stick to the law of cosines. So then the last thing I got to find is angle B. And for that one, I can just subtract. So 180 minus 105.66 minus 31.98. And I get angle B 42.36 degrees. Questions? So again, be really careful with your parentheses. My advice is when you're doing this on your quiz, like at least give me this step, because if you round wrong or you type it in wrong or you do some stupid thing to get a wrong answer and you don't give me what you plugged in your calculator, I can give you no partial credit. Don't do that. Okay, at least show me what you're plugging in. Same thing with law of sines. Like maybe you don't have to take it to the next step where you're cross multiplying and dividing, but at least show me the setup. With no setup, you get no partial credit. And it takes one little missed decimal or one missed number to type it in wrong in your calculator and get it totally wrong. Don't do it. All right, so this one, again, it's almost like a regular easy problem disguised as a word problem, but it just says find angle theta between the two paces for both the carnivore and the herbivore. So you get given two triangles. Both of them have all three side lengths. So this is side, side, side. And for both of them, they want where theta is. So if I just label this, like if this was A and this is B, and this is C, and this is A, and this is B, and this is C, then I'm solving for A for both triangles. So go ahead and do that. All right, so this time they gave you, like both the thetas were the largest angle, so the order didn't even matter. But if it had been in a different order, remember, you can either stick to law of cosines the whole time. It's only when you switch to law of sines that you have to worry about the order, okay? But for the angle of theta on the carnivore, you should have gotten 156.85, and the theta on the herbivore, 99.59 degrees. It didn't say to round it, but it will be specific on your quiz. Usually 2 decimal places unless it states otherwise. Sometimes the word problems are a little bit different, but questions on those. Again, careful with your parentheses. Yep.
Are there questions from last night's work on the quiz, like those kind of work?
So I would say you could see stuff with like the parallel lines. I think the quiz's questions, in my opinion, are slightly easier, but you will definitely see stuff like that again. Yeah. All right, so this one says, you are on island B. What bearing should you navigate to go to island C? So now we're dealing with bearings again, but this time we're looking for the bearing instead of given the bearing and trying to find the measurement. So first thing is yours is missing the side lengths, right? It's 16 on the left, 22 on the right, and 23 on the bottom. So if I'm on island B, what bearing would I go to navigate C? So if I'm starting here and I want to come to here, in what direction am I going, north or south first? North. And then I would turn and go what, east or west? West. So what I have to do is fill in this space in between. So if you had drawn out your north, south, east lines, then what I'm looking for is this angle here. How can I find that? Then what? So that's where the order has to matter. If you stick to law of cosines, it doesn't matter the order. The order matters when you switch from cosine to sines. Does that make sense? So even though I don't necessarily have to do the largest if I'm just solving for a single angle using cosine, it's when you switch, right? So is that the safest bet? Yes, but you don't have to do that.
Could you go for angle A and then subtract it from 90?
Oh, you guys are making this so much harder than it needs to be. This right here, can you find that? Can you find that angle B? Yeah? Can you find a single angle if you're given all three sides? Yes, you could do that, right? And then you would subtract it from 90. Yes? Yeah, we see that? Okay, so let's find angle B. So I need to find the angle inside the triangle. We're going to call that angle B. Okay, so the cosine of B would be a squared plus c squared minus b squared over 2ac. So I'm going to do cosine -1 of a squared, which is 22, c squared, 23, minus b squared, which would be 16 over 2 times 22 times 23. Type it in the calculator. Again, making sure you group. And I get the angle inside 41.58 degrees, which means that the angle on the outside, if I did 90 minus that, would be 48.42 degrees. And again, it should tell you, like, maybe round it to nearest 10th or 100th, whatever it is. That's the degree that goes in between the north and west. So don't forget, if it says bearing, you do need direction. It would be north 48.42 degrees west. You would need all three parts of that.
And put the degree symbol?
Mm-hmm. Good so far. So, again, I've said it like 17 times. So you're going to see law of cosines and law of sines, word problems put in together. Obviously, that's when you got to know side, 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 angle, side. I'm going law of cosines. Angle, side, side, or angle, angle, side. I'm going with law of sines. You won't be able to do the other one. So it should make sense. It's not like you can have both and choose. You'd have to do one or the other. All right, and then this section ends with the other area formula. So there's an area formula dealing with sines, and then this one is dealing with, well, not really law of cosines, but it has three sides. So Heron's area formula would be if you knew nothing about the angles inside the triangle, but you knew all three sides. So the area formula is the square root of s times s minus a times s minus b times s minus c. And to find s, you add the three sides and divide by 2. So not the average because you're dividing by 2, but similar. Really important is that you do not round s. So s will eventually terminate. It's divided by 2, so it will eventually terminate, but it could have 4 digits after the decimal place. You need to keep all 4. So if my s is 1.2345, 2, 3, 4, 5, you need to keep that every single time. But again, your calculator does the work here. Just type it in. All right, so find the area of the triangle with the given side lengths. A gives you A is 5, B is 7, and C is 10. First thing I'm going to find is S. So S is A plus B plus C divided by 2, which in this case would be 22 divided by 2, a nice whole number like 11. Then area equals the square root of S, which is 11, times 11, or S minus A, which is 5, S minus B, and S minus C. So you can simplify it and then plug it in your calculator, or you can let your calculator do the entire thing. I would second square root it. 11, parentheses, 11 minus 5, parentheses, parentheses, 11 minus 7, close the parentheses, open the parentheses, 11 minus 10, close the parentheses, and I get 16.24. 25, sorry. So then for the last one, S would equal 3.05 plus 0.75 plus 2.45 divided by 2. which is 3.125. And we're not going to round it. You're going to leave that every single time. So 3.125 times 3.125 minus 3.05. 3.125 minus 0.75 and 3.125 minus 2.45. And I get 0.61 units. God bless you. So with extra time, you can do things like check, like simplify these and then type it in your calculator. Again, make sure it's the same answer, that kind of stuff. But you've got a calculator there. You might as well let it do the work for you. Just be really careful how you type it in. And again, my advice is you're going to make sure on the quiz, you're going to give me this line. You're going to show me what S equals. Okay, so that if you do type it in your calculator incorrectly and get it wrong, you don't lose all the points. Questions for me? All right, so that's the end of the new stuff. Tomorrow we're going to do some real world application of it and review, and then your quiz is Monday for those two sections.